We will only, I'll just introduce you to one idea on how to pass 2D arrays as parameters. And after that, it's all no specific, whatever you ask, I'll try to answer. So passing 2D arrays, it's a, so in the last class, we read, there's one program. Which one is it? array.c. Okay. I'm in, okay, I'm here. Thank you. Read matrix function. Okay. So here, in order to, thank you, Harsh. Thank you very much. So this is the program that we were looking at. So we wanted to write a program where we have one function to read the matrices and another function to do some computation on line number 39. That can be anything, so we are not doing anything there. And then print matrix function. Okay. In order to make it a bit more clear, I will remove this pragma hash define n because it will confuse you. You will keep thinking that it is a variable. It's not a variable, it's a constant. So we are defining a hotel with 3 floors and and 4 rooms per each floor. Okay, does it make sense? Line number 34, 3 floors and 4 rooms per each floor. That is our hotel. Okay, 3 floors and 4 rooms per floor. That is the, and so now we want to read stuff into some whatever content into this hotel rooms or matrix. Okay, so we'll just call it as 3x4 matrix. But whenever you get doubt, you resort back to this to this example, 3 floors per and 4 rooms per each floor. And so here, now let's come to the signature. When we are reading when we are passing a parameter, a 2-dimensional array as a parameter, we have to pass all the dimensions of the array except the first dimension. So here, the second dimension of array that we want to pass, it is 4. Second dimension, that is the number of rooms per floor is 4. So we need to have 4 here. And the first dimension, we can leave it. And then we need to, and then we need to give what is the first dimension, n. Okay, let's call it as n. And then the way we have to read it is, that's all. So in order to again make it kind of easy, I will just do for I equal to 0, I less than or equal to n. N is the number of, so remember n is equal to 3. N is equal to 3. And I is equal to I plus 1. And then for j is equal to 0, j less than 4, and j is equal to j plus 1. Scanf here. And I'll just copy this whole. Is there anything, is the code for read matrix looking all right now? Are there any bugs in it? a signature. So we cannot, when we are passing a multi-dimensional array, let's say two-dimensional array, the first dimension we just leave it open with square brackets, and the other dimension we have to explicitly specify. We cannot define it. The compiler will give an error. Like for example, let's see if we keep 3 here, then I think you should get an error. Yeah, it should not. You should leave it empty. We should not. What if you are taking both the dimensions from the user? Then it's going to be a challenge. We have to. There are ways to resolve this. For the time being, we'll just be it like this. Okay. There are ways to take care of it to some extent. Are you all with me on this code? So we are reading and printing a 2D matrix. And let's compile this program, CP21A. GCC, what should I do? Read matrix. Oh, thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I'm not printing nicely. You can see everything is getting printed. How should I put, what are the changes I need to put? After printing every row, I need to print /n, and every row also, I think it is good if I allocate 5 columns to print every row, or /t is also good. Okay, even this will work. Dot a dot out. I'll just copy, paste. See? Good, all good. So you're all, any questions here? I will show the code again. See. /t is tab. So whenever you get a doubt, now you just have to try it out and see what it is. That's all. Are you all with me on this example? What is %d? It allocates 5 columns, and it whatever it has to print. I'm fixing my one. Okay, there is trouble here. Let's leave it as it is. Sorry, I'm back. So show the top of the program. Ronak, what is the use of defining a function beforehand? Call we or writing marks which cell pointer is passing through is. Yes, because we are A contains the address. When we are passing, yesterday we have looked that when we say read matrix hotel, hotel contains the that the base address of the array, and that's what is being passed here. So we are good. Yeah, the contents of the matrix are getting changed. So in fact, if you if you see this array, we can use hash defined function, but I don't want you to get confused with in this program, in this function. I just thought, no, for the time being, just keep it aside. Okay. And also, yeah, the other thing is you should, this is n by m matrix. That's the notation that we are using. Okay, so now I'm all yours. This is what, this is the only idea I would like to discuss. So for the time being, let's work with fixed dimensions, and we will. Yes, yeah. Yes, Pranav, you can. So I want to cover few things here in this example. So here we have read marks underscore marks comma number of students. Okay. So I would let's try to go through this program. This read, this is sum array function where we read marks of the students from. So we read the marks of the students, we do some computation, we print. Okay, so let's spend 15 minutes of time. So let's do this. Time is 10:30. Let's say I am with you for 1 more hour. 15 minutes I will we will review pointers and arrays. So what do you want to know about pointers? Where should I start? Let's say we'll start with pointers and then we will revisit arrays again. So what do you want to know about pointers? Specific questions. Application we have already seen, Ayush. Because when you want to read something through via a function, then without knowing the address, you cannot change the value. So, and later you will learn dynamic data structures where it's all about pointers. Like when you work with what are called as linked list. I think all of you should put the messages in the, don't put me direct messages because your friends will be out of context. And I have to explain how do we define an array of strings. So Prakul, we will take it up later. How do we pass pointers through functions? Can we add pointers? Can we go through the briefly, like taking the order in which it debugs after taking pointers? What is the use of defining other functions before the main function? Is there some way to concatenate strings in C? Yes, we will talk about strings after your quiz. Okay. So what I will do is, I will review the basic topics again, basic pointers 101. I'll have a folder review 1, and then ptr.c. So what I would say is, while you may have many questions, those questions will be answered in some period of time. But what I would like you to do is, if you understand what I am telling now, then you are good. That's it. You don't need anything else for the time being. Okay. So just pay attention to me. We are reviewing pointers one more time. We are declaring a variable A, and we are declaring one more variable called as, whose name is ptra. So all of you, I want you to write down the questions that you have in your own book, and we will answer them, okay? Because answering them requires detour. So I want you to all to stick to the basics. Stick to the basics. Okay. What is the type of the variable A here? What is the type of the variable? Just follow along with me. The type of the variable A is int. And what is the type of the variable? When we say the type of a variable is int, what does it mean? That in the memory associated, if A is a container, in the memory associated with that variable, we are storing an integer. We are storing an integer. And when we say ptra, the variable ptra, it is a pointer to an integer. What does it mean? It is holding, what does it hold? It holds an address. And at that address, what is the, at that address, at that particular memory address, we are storing an integer. All right. So let's understand this. Okay, let's understand this. So let's go back here and yeah. So let's say we say A is equal to 1, star ptr is equal to 2, printf %d /n A. So request everyone to just pay attention. Other questions that you have, you hold on to them. Okay. We will all right. So when we print this program, what will be the output? What will be the output? The output is 2. Is there anyone who thinks no, it's the other way? It will be 1. Manoj thinks it is 1. Yesh thinks it is 1. Amoga thinks it is 1. Sankalp thinks it is 1. Okay, good. So let's see what happens. So GCC, we are, what is the program? We are now in review 1, GCC ptr.c. gcc minus gptr.c gdba.out break main It's okay, it's just a warning, so don't worry about it. Oh, there is this thing. It's blocking. Okay, now we are good. So now we put a breakpoint on main. We are running the program. And so now we are printing A. So A has interesting. So some of you said 2, some of you said 1. Okay. I thought it is the output should be 2, but now I think it is 1. So why is it 1? Is there a bug in this program? Does this program make sense? Now I think about it. Does this program make sense? Don't worry about why it may. %d is not an integer. So what can happen actually is, this program can actually crash. Do you know why the program can crash? I have some interesting thing to share here. As I was telling in the other class, through bugs only we will. Okay, let's see what happens in this, whether it will crashes or doesn't crash. Let's see. It may or may not crash, who knows. See, it got a segmentation fault. This is what is called a segmentation fault. So let's run it at the keyboard itself and see what happens without. Yay, did anyone got segmentation fault? So we got our first segmentation fault in this course. Did anyone get it while writing your phone program? So can someone explain why we are getting segmentation, why we got segmentation fault? Okay, let's try to understand this push. Let's try to understand why we are trying to access unallocated memory. Awesome, Gnan Prakash. See, what is happening here is, so break main, and so now we are running the program. So you print A, okay. We are at line number 4. Now we are on line number 8. So we are so we are on line number 8. Line number 8 is not executed. So when we print A, this is what we are getting. A is containing some garbage value. And when we print PTR A, so PTR A happened to be equal to 0. Listen to me, guys. Listen to me. Okay, listen to me. Okay, and then so this is your memory. This is your memory. So usually what happens is, this is your RAM. Depending upon the operating system, this kind of changes. But if you look at the RAM, the address of the RAM, let's say if it starts from 0th byte and it keeps on going up, And so usually at the zeroth addresses in many operating systems, we have BIOS, and then followed by that the functionality or code or instructions associated with OS will be there. If you try to update any of these memory locations, we don't have permissions. So the operating system will raise a signal called as SIG-SEG signal, and as a result of which your program crashes with a segmentation fault. So here in this program on line number 10, so now let's see, this is the program memory. So let's say this is associated with A. Okay, this is A, and SIG-SEG, I think SIG-SEG B or something like that, SIG-SEG B. So, so variable A, what does variable A contain? Now, print A. So we didn't yet execute line 8, so we are saying next. So line 8 got executed. So what does variable A contain? Variable A contains 1. Variable A contains 1. And what is the address of the variable A? Print it is 2EF. The address of the variable is the address of the variable is 2EF. All right. And now there is one more variable. What is the other variable? The other variable is PTRA. This is PTRA. And what does PTRA contain? What does PTRA contain? In this particular case, it could contain any garbage value. It can contain any garbage value. In this particular case, PTRA is containing 0. It's not initialized yet. There is no guarantee it has to be equal to 0. But in this particular case, it turns out it is equal to 0. Or it's a garbage value. So in general, we can say it's a garbage value. And what is the address of the variable PTRA? Do you have the address of the variable PTRA? So if I print, we get the, no, address of the variable PTRA is not garbage. There is a specific address. 2EF is the memory location at which variable A is allocated memory. 2E8 is the memory location at which PTRA variable is allocated memory. 2E4 for variable A and 2E8 for PTRA. Does this make sense? Yes or no? Are you all with me here? On line number 12, coming to line number, so when we do star PTRA on line number, what is that dereferencing operation that we have learned? When we apply, when we say star PTRA is equal to 2, whatever the address that is present in PTRA variable, which is 0, we go to that memory location. We go to that memory location. We go to that memory location and we try to update. In this particular case, 0 is the address. So we go to the memory location and we want to write into this memory location 2. But we don't have the permission, so we get a zigzag fault. We don't have write permissions to that memory location. Are you all with me here? Okay. Very simple. Now here in the printf statement, why not PTRA containing the, because we have to put, we cannot put magic, PTRA doesn't contain magically the address of A. Now, whatever may be the address, at that particular address, we don't have permission, we will get a sig fault. If it is 0, sometimes it could be some value where, it is not where we have permission, but Yeah, but it's not supposed to be pointing there. Okay. So now one question. So printf, how many parameters we are passing to printf here? Two parameters. Two parameters. One is this one. This whole thing is one parameter. This is second. This is second parameter. So now, what do we pass? If you leave the first parameter aside, we are passing to printf. What is the second parameter value that is being passed to printf? 1, and that is what gets printed as a part of the output. Okay. So now we want to fix this problem. We want to fix this program, and so we want to change the program like this. You want to change the program like this. PTRA is equal to address of PTRA. Sorry, address of A. Now, if you run the program, what will happen? It will print 2. So now let's run this program and see what happens. GCC -G gdb a.out break main run next. So now let's see the memory map here. I want you to keep track of this memory map all the time so that it's easy for you. I think I'm telling you, so this is, I'm showing you the alive, how things are happening underneath. Yes, then S path. If it's not an unmodifiable location, you don't get any seg fault. So what is the address of the variable A? This is variable A. The address of the variable A is 2DC. That is the address of the variable A. And print address of PTRA is 2E0. Address of 2E0. Yes. Okay. Next. So now, if we print A, okay, next. So after this code got executed, now we are on line number 10. What will be the contents of the variable A? What will be the contents of variable A when we are, the contents of variable A is 1. What will be the contents of PTRA? We still didn't execute line number 10. We are still about to execute. Let's say, so before that it is garbage value. It is garbage value actually, but after we execute it, and if you print PTRA, then you see that PTRA now contains the address of the variable. Are you all with me here till this point? All the students who are having trouble with pointers, are you with me? So now once PTRA has 2DC, line number, yeah, we are getting to line number 12. So once PTRA, it contains the address of the variable A, that is 2DC. Now we are on line number 12. We are on line number 12. The semantics of this line number 12 statement is this star operator, what it says is whatever the address that is present in this PTR variable, that is this, in this particular case, it is the address of the variable A. Go to that address and assign this value, put that value there. Are you with me on this star operator? This is called as dereferencing operator. Go to the address and to that, whatever the address that is present in PTRA, go to that address, and from there, that is why it is a pointer. Okay, the reason is this is a pointer. You're pointing to this memory location. Go to this address. When we say star PTRA, go to this memory location and update. No, not PTRA still contains 2DC. Does PTRA change? No. Please understand. PTRA doesn't change. Whatever the address to which PTRA points to, that will get changed. PTRA still remains the same. PTRA still remains the same. Okay. So now if I say print PTRA, does PTRA change? It's still the same. Does A change? Did A change? It changes. Okay, that's it. Are you all with me on this pointer example, small simple example? So there is this question, if you remove, if you remove on line number 12, PTRA is equal to 2, then what happens on line number 12? Then you override PTRA with 2DC. Yeah, that variable itself gets modified. Are you with me here? And that's what we are doing on line number 10, right? Are you with me here? Okay, awesome. So now let's continue this story. We will have a void set val int star PTR. What will happen in this case? Both are same. Okay, so we can use both. It's okay. Yeah. What will happen? Oh, set var val. Set var. What will be the output? What will be the PTR value? What will PTR hold? What will PTR hold? PTR, when we call on line number 17 set var, what will it contains the address of the variable A. Since it contains the address of the variable A, when we say star PTR is equal to 2, we go to that address and modify it. Does this make sense? And whether line number 17, whether is this same as this ampersand A, are these the same? Line number 17 and line number 18 are the same? They are exactly the same. If you are passing the address of A, they are exactly the same. And now, does it make sense why scanf requires address of A and why printf just requires A? Why scanf requires address of A? Scanf requires address of A because you want to go and modify that memory location to store a, whereas printf just requires the value to print. Printf doesn't require the address of A. Printf just requires the value and it just gets the value as a parameter and it just prints it on the screen. Now, do you understand the difference between scanf and printf? So this is, yeah, this is all about pointers, that's all. So shall we, if you are all doing good on this, shall we move on and try to look at arrays, one-dimensional arrays, and see what happens? How do you pass? What are the challenges there? And okay, so let's look at one-dimensional arrays. Okay, let's look at this example itself. Let me write. Okay, so there are many possibilities. I think I want you to, if you get this basic idea right, you can try it out and see. Scanf function, and I request everyone to send messages in the public box. Okay, again, one more time, it will be easy for all of us. 1D array.c hash include stdio.h. Okay, so now we have a simple array int a of 10. Okay, so yeah, so let's say we write a small loop int I is equal to 1, I is equal to 0, I less than 9 plus plus I, a of I is equal to I times I. Okay, some simple initialization loop we are having. I less than or equal to 9. Okay, good. All right. And then maybe we'll have another loop. It says sum is equal to sum plus. Yeah, I'm just writing some code. Okay, so sum is equal to 0. Main is, yeah, it's the default is int, no? So there are always defaults. So, and by this time you should have figured this out if you read the book. Yeah, we don't need, yeah. How to execute loop again and again. Yeah, on line number 8, I introduced something. When there is only one statement in the body of a loop, you don't need to put left and right parentheses, not left and right flower brackets. Okay, so now we will do the story. Pointers and arrays are very closely related to each other. Okay, 1D array.c gdb a.out break main run next. So now if I print a, print int star a, so I want you again pay attention, guys. We will slowly things gets complex. Not complex, but if you understand the basic thing, you are good. What is the base address? A contains the variable A. Okay, let me do one more thing. Print address of A. What? Oh, it is showing this. Just give me a moment. So yesterday it showed different. Okay. So yeah. No, int star and they are different. So let's continue. So now if I print A, or it is GDB is being smart here and it knows A is an array. So it is printing all the entries, all the elements of the array A. Are you with me here? When we do print A, GDB is being smart. It knows the type of A, and so it is printing the elements of the array A. But if you print what actually it means is A holds the variable A. It holds variable A. It holds the base address of the array variable A. So somewhere in the memory there will be variable A, and it holds the base address of the array. The base address of the array is 2C0. Okay, so starting from 2C0, so the array starts from 2C0, and then the first 4 bytes it will be A of 0, and then the next 4 bytes it will be A of 1, the next 4 bytes it will be A of 2, so on and so forth. Are you with me here? So if you see print address of A of 0, this is what you get. Are you able to see here that print address of the 0th element? The address of the first element is obtained by adding 4 bytes to it. The address of the second element is obtained by adding 4 more bytes to the next offset. So if you know the base address, yes, array elements will always occupy consecutive bytes. So if you know the base address, will you be able to calculate any address of any element? Yes or no? We just have to add the appropriate offset. That's all. So the variable A, the array name contains the array A. It contains the base address. So the address of A, what is the expression for this address of the element A of I? What is the address of what is the expression for this? It is just A plus 4i, because A contains the base address or address of A of 0, but simplest thing is, so this is the same, A of 0 plus 4i, this is the same, base address plus 4i, these are all the same. Are you with me? So all these three are the same. Any questions here? Any questions here? So shall I move to the next idea? A 10 element array takes 44 one extra for base address. A 10 element array, just think of it as it takes 40 bytes of memory. Don't worry about the extra base. So now we want to read array, and remember, in order to read array, we need to know its size. We need to know its size. Pay attention, guys, pay attention. Okay. All right. So now, if you see this code, yeah, let's clear all my drawings. So we are writing read array A, and we pass 10 as input. Let's run this program and see what will happen. GCC 1D array.c. Is the sum of first squares is 285? What is that formula? N into n plus 1 into 2n plus 1 by 6. Is this 285? Okay, great. So now what is happening? What is happening on line number 13? The variable, the array variable A contains the base address of the array. And when we call the function read array, what will B contain? What will B contain? What will B contain? So if you think about it, so this is yeah, awesome, you're all doing good. So this is A, and then this is the actual array, A of 0, A of 1, so on and so forth. And this contains a pointer to this location. And then when we call, okay, I'm using a different color for B so that it doesn't get mixed up. This is the memory location for B. So when we are calling read array, whatever the address that is present in A, let's say it is 2E0, that gets copied into 2E0, into the variable B, into the parameter B. Are you all with me here that the parameter B contains the base address of the array? It is very, very important for you. Once the parameter, once B has the base address of the array, will it be able to modify any of the elements in the array? Right? I have the base address, I should be able to modify any of the elements. So in terms of actual, from the compiler perspective, B of I is equal to something, B of I is equal to something. This is equal to star plus B plus 4i. So you get the address of the element, you go to that address and modify it. Does this make sense? What we are seeing here? But on the flip side, if you have something here and we say B of I plus whatever it is, then this is equal to star B plus 4i. So this is a read operation if it is occurring on the right side, and this is a write operation if this is occurring on the left side. But the address, important thing is the address calculation is, if we know the base address, then we will be able to modify any of the elements. Are you with me here? All of you? Happy so far in this review session? I know some of you have some interesting, tricky questions. I would like you to find answers to those tricky questions by yourselves. The basic fundamentals, it should be clear. Now, I have one more thing. Here, instead of A of read array, here, if I pass something like this, what will happen? B doesn't occupy 44 bytes, Samoga. B is just a pointer to an integer. So it just occupies some 8 bytes because address requires some 8 bytes. What will be the output? Will the output be the same? Okay, it will be different. It is kind of undefined. Okay. What if we do this? Is this all right? Is this allowed? A of 4, A of 5, A of 6, A of 7, A of 8, A of 9. Yeah. Does this make sense? Line number 13 now. Line number 13. What elements will be initialized? Using the approach on line number 13, what elements will be initialized? The element A of 4, A of 5, A of 6, A of 7, A of 8, A of 9 will be initialized, and they will be initialized with what values? They will be initialized with the values 0, 1, 4, 9, 16. Does it make sense? Yeah, first 4 would be garbage. That's true. Okay, you are all fantastic now. If you understood this, so here we are on line 13, we are passing the address of the 4th element. Okay, so from there we are accessing A of 4, A of 5, A of 6, A of 7, so on and so forth. So in order to see, let's say GCC, let's run it one more time, GCC 1D array.c minus G control L GDB A dot out break main break read array run. Okay, so now if you see so this is the base address of the array, and now we are printing the address. Yeah. So now you see the address of the base address, address of the 0th element and address of the 4th element we have printed. Okay. So now we are calling read array with the A of address of A of 4. So then what will B contain? What will B contain? Does it B contain 2C0 or 2D0? B contains 2D0, right? And what is the size that we are passing? The size that we are passing is, so that means A of 4, A of 5, A of 6, A of 7, A of 8. These are all valid elements. Okay, thank you, Devish. Oh, no, Devish, it's not 2D1, 2D2. You have to 2D0, 2D4, 2D8. plus 4. Okay, so now continue. Okay, okay, understood. That's what I thought you would have forgotten. So now if you see print B, yeah. Huh, how did print B got 2C0? Did I change the code or I didn't save the code or it should? I didn't save the code. So yeah. Yeah, I didn't save the code. Without changing the code, I am doing the same debugging. Okay. Without what is happening. All my fancy theory got no, it will go waste. So and yeah, so now yeah, it's not we are still good. So we run the program. Next, so make a note, print no address of a of 0, that is the base address of the array. Print this, continue. We are in the read array. Why am I still getting this size 0? Okay, we are good. Okay, so yeah, so now B contains, if you see, this is the address of the fourth element, A of 4, and B now contains the address of the fourth element. So from there we are modifying the elements. We are modifying 5 consecutive elements from there. Does this make sense? Those of you who are having an issue? Okay, that's all. Okay, 2 important ideas, nice ideas covered. What else you want to learn or review? How versed you need to be, not for the exam, but you learn GDB over time. It's okay. But learning to use GDB is good because you can do many cool things. Like for example, I got a doubt, I go up in the stack, down in the stack, and print addresses, do lots of interesting stuff. So the time for you to debug it will be very fast. You got a segmentation error, then what happens is, yeah, there is a specific reason why we need to give other dimensions. Now, can you tell me why we need to give, it's a, okay. So someone who can tell me why we need to give other dimensions in this code, they will, at some point in time when we meet, I'll give you a treat, small treat, chai, maybe. Chai is cheap, but something more. So where is this read function, read matrix function? The question is there any reason why we need to have 4 here? Awesome, Tejas. So Tejas Srivatsava gets a treat. Because we need 4 columns. Yeah. So now, in order to understand this, let's say if it's a 3 by 3, this is not, by the way, it's not easy to kind of see. I wouldn't have got it. No, so when I'm learning it for the first time, I'm very confident about it. So this is row 0, this is row 1, this is row 2, this is column 0, column 1, column 2, column 3. But your memory is linear, right? It's not 2-dimensional. Nah? So what happens is this will be unfurled, this will be mapped into a linear array of bytes. This will be mapped into a linear array of bytes. So what happens is, if this is the array, so first A of 0, 1 gets stored, and then A of 0, sorry, A of 0, 0, A of 0, 1, A of 0, 2, A of 0, 3, and then starts A of 1, 0, so on and so forth. So if you see, row 0 is first stored linearly in the memory, followed by that row 1 will be stored linearly in the memory, so on and so forth. So if you know the base address, so can you tell me the expression for this now? Can you tell me the expression address for this? Address of A of ij? What is the expression for A of ij in this example? A plus 4j. So how many, the number of rows we have to skip. So if I is equal to 0, so the number of rows that we have to skip. So each row is how many bytes? Each row, how many bytes are required? 16 bytes, right? Can I say 16j plus 16i plus 4 times j? Is this a valid thing to say? Is this okay? 16i plus a plus 16i plus 4j. So now tell me one thing. So what happens is, when we are passing this array as a parameter, this knowing how many rows to skip, when it becomes makes the job of the compiler easy. So because of that, having all the other dimensions and just leaving the first step, because if it doesn't know any of these dimensions, then it's a problem. How many rows to skip? Do you see the problem? If you don't give the second dimension as input, how many rows to skip? Not how many rows, the size of each row would not be apparent. If you don't have this, the size of each row would not be apparent, and that makes it little bit difficult for address calculation. This is rough explanation, don't bother about it. Okay, this is but there are ways to take care of it, but this is rough explanation. Anyway, so if you are kind of confused on the last point, leave it. But this much, are you all with me on this green circle? Do you understand this part? This whole address calculation part? Okay. Awesome. So yeah, what else you want to learn? Okay. Time is 11:26. So I know it's, I'm just hanging around to help you. If you can drop off. No strings, they just. The exam pattern still I didn't think about. I'll think at the end of, could you just give a brief overview about the quiz as in the same format? What is the pattern? Same question. I didn't think about it. There's a lot of time for tomorrow. I will give one very super small programming problem. And there will be objective questions and one or two small programming, very small, very simple problems will be given. And you have to write your code in Code Tantra, no VS Code. Okay. Yeah, that is important, guys. If there is only, you cannot touch anything except your Code Tantra browser tab. Okay. Simple for you or simple for us? Can we check code by running? I think you cannot use GDB, but you can. I should be able to run the programs. Let's do. You can run the program. I will give you some test cases. It will all be good. We don't have to upload any documents tomorrow. Yeah, I will. It's a painful thing.